Hello, everyone. This is Belinda Carr, and you're listening to my podcast on building science, products, and technology. As we know, the construction industry is ripe for disruption and automation. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with Alessandro Arnulfo, founder and CEO of Messana Hydronic Technologies in California. Thanks for joining us, Alessandro.
Thank you for giving me the opportunity to speak with you.
So, to anyone who hasn't heard of your company before, you are trying to change the way buildings are conditioned and eventually reduce their carbon footprint. And you're doing this by introducing radiant heating and radiant cooling to homes and buildings rather than traditional HVAC systems that rely on forced air or convection heating and cooling. Is that right?
Yeah, that's actually very, very correct. So radiant versus convection air system. So technically, we do heating and cooling through radiant. The big challenge, obviously, is the cooling aspect.
Yes.
And so the technology of radiant cooling is not as known as radiant heating, but they are very similar. It's I like to call radiant cooling like negative radiant heating, because basically that's what it is. Radiant heating, you warm up a surface, and that such surface will radiate heat. And in radiant cooling, you do the opposite. You cool a surface, and then that surface will receive heat radiation, and then will extract heat from the building. So
that's a very, very exciting new technology, and I'm looking forward to diving into the specifics of how this works. But before we do that, I'm curious, what does the name Messana mean?
Well, I need to go back a little bit on the history of Messana Hydronic Technologies. So this all started back in 2010. First of all, you probably already noticed from my accent, I'm Italian, and I've been living in the US, in California, for 23 years. And I have a master in electronic, and I was attracted by the Silicon Valley. So I came here in California as an engineer, as a software engineer. And I ended up starting Messana because in 2010, I was remodeling my house here in the US, and I was looking into, I used to have one of those air system blowing from the floor, making noises, and I was remodeling my house, building a new family, and I want to have something more comfortable. I want to do something different, and I looked a little bit at what was available on the market, and obviously radiant heating was, the option for heating. But then I started to look, is there something like radiant cooling? And
which is necessary when you're living in California.
Yes, absolutely. And so I met this person in Italy whose name is Messana, Roberto Messana. And he happened to be a world leader in the radiant cooling technology. So he was already doing radiant cooling in Italy for many years. And in one of my trips to Italy, I decided to meet him, and we became friends. And he always had the dream of conditioning the USA, reconditioning the USA, because for him the USA is where the air conditioning started back with the Carrier. And that was his dream. And he was doing radiant cooling using a drywall technology. And things change a little bit right now, but back on those days in Italy, drywall was not very popular. And we were still building houses with bricks, and so there was not light construction with drywall. Now that changed, but here in the US, every house is built out of drywall. So I literally told him, I mean, you did the perfect product for the US market, not for the Italian market. And like a friendship started, I decided to try that technology at my own house. And I got really intrigued by such technology. And I kind of deviated my career path, and I started Messana. And so that's why the name of the company. So it's the name of Roberto Messana.
Well, that's a nice story.
So that's how that's the story behind the name. And we are still partnered with him. And then together we needed to adapt that technology more to the US way of building. And so we discussed together about a new fitting technology, and then we actually we have a patent in common that is the way that we connect the panel together. So the patent will be the fitting that we have here in the panel. So
let's dive into the panel itself and how it differs from traditional HVAC. So everyone knows people might know the three main methods of heat movement are conduction, convection, and radiation. So traditional HVAC systems with the furnace and a condensing unit outside, they work on convection of forced air. So how does that differ than what the radiant cooling and radiant heating systems that you
as you mentioned, to transfer energy, to transmit heat, there are three different ways. You by convection, which means through a fluid, in this case would be air, and then you will be transmitting air, hot air or cold air, to cool or heating everything that is around. This method is inefficient. First of all, moving air requires a lot of energy compared to moving energy through water. And also it's uncomfortable. You move particles. Now in the era of COVID, we all realize how air system can help the spreading of disease. And
and you also feel that blast of cold air in summer, blast of warm air in winter.
Yes, there are many other reasons why air is not comfortable. In our skin, we have a temperature sensor that are actually measuring radiation. So our skin measure heating, and we have heating and cooling sensor that are measuring radiation, and so no air. Blowing cold air actually irritates, make us losing concentration, and we'll never be able to satisfy the need of the body, because when it blows cold air, we feel cold. When we don't blow, we feel hot. So it's on, off, and we'll never have the perfect comfort. We achieve a good comfort when our body can actually radiate energy. So our body temperature is 98, 97 degrees, and our body, because it's a mechanic machine, and always need to, we always generate heat in excess that we need to release. And so the best way to release heat is by radiation. And so having a system that allows our body to radiate will make it very comfortable and energy efficient. This is why radiant systems are considered to be more effective and more green than a traditional air conditioning system.
So radiant heating and radiant cooling for homes they already use it for underfloor heating in bathrooms and stuff. I've seen that used around the States. But the logic behind it is that you run hot water or cold water through pipes, either in your ground or your wall or your ceiling. And then the pipes cool down or they heat up, and then they radiate cold, well, not air, but they radiate.
They radiate heat, or they absorb heat, so negative heating, let's call it in this way. Yeah, unfortunately, there is not a physical definition of radiant cooling. There is radiant heating, and it's like the way that you transmit heat through radiation. There is not a similar definition for radiant cooling, and the way that I describe it as a negative radiant heating. We determine radiant cooling, we describe a technology to use radiant heat to cool a building, basically.
So when you run cold water through those same pipes in summer, you're saying that those pipes basically absorb heat from the air?
So I have here, this is a panel that we typically install on the ceiling, and there will be cold water going through, there is a supply and then a return pipe. And so we will pump water into this serpentine. And so this is the radiant pipe, basically. And this pipe is connected to this metal aluminum plate, and those help to transfer the heat. So then this will be installed typically on the ceiling, and then you cover with drywall. And so this becomes like a radiator. So if you, let's do the sample of heating, which is more simple.
Understandable, yeah.
So you run hot water, this pipe will get warmer, and then the heat by conduction will transmit on the metal, and then all the metal will become warmer, and therefore also the layer of drywall that is on top. And so you are going to have like a surface on the ceiling that will be warm. So that surface, because there is a differential temperature between the ceiling and everything else in the room, there will be radiation. And the fact that it's on the ceiling is just a mental barrier that we have. Oh, heat goes up. Why do you do heating on the ceiling? We're doing radiant, and so there is no air movement. It's not a convection system. So if you just think about the sun is up there. So, and it's still radiating. If you walk on a beach in the summer, it's pretty warm, right? So it's coming from the sun from above, and it's just radiation. And same thing, you know, if you run cold water, then you will create a cold surface on the ceiling, and then through the ceiling, all the heat that is in the room, everything that has a temperature that is above the temperature of the ceiling, let's say we put the ceiling to 60, 55 degrees. So everything in the room, including our body, will radiate heat to the ceiling. And then this surface will absorb the heat, and the temperature in the water becomes a little bit warmer. And then this warmer water is pumped out of the house into the, typically it's on a chiller of a heat pump, and then is going to be cooled back and sent back to the panel. So it's extraction of heat.
So you have several components of this system. You talked about the panel behind you. There are these modular panels about 2 feet by 3 feet or so, and they are attached to furring strips and screwed on to the ceiling before drywall goes on there. Correct. Do you also attach that to walls and to floors, or just to ceilings?
The ceiling is by far the best surface in a building to do radiant in general, heating or cooling. And why is that? Well, there are many reasons. The most logical reason is that on the ceiling, there is a huge unobstructed surface that can see,
the whole room.
In the room. If you do it on the floor, there will be furniture, flooring, and so it can be more inefficient. So you see less. Okay, that would be the reason number one. The reason number two is that it combines so well with the drywall. Drywall is just like a half inch or a 5/8 gypsum that has a very low thermal mass and R value. So it's a good media to transmit the heat. Okay. So that would be the, compared to maybe like a floor where you might have carpet or there will be a thick floor. Yes. So there is a lot of thermal mass. So the response of the system will be much slower.
Quicker. Yeah, for floors will be
much
slower.
quicker,
yes.
on the ceiling, absolutely. And another critical reason to do it on the ceiling is the fact that when we do radiant cooling on the ceiling, there is always a little bit of convection that happens. So let me explain. So you put very cold temperature on the ceiling. Let's say your ceiling is 55 degrees. So the air in contact with the ceiling that has 70-degree air, 75-degree airs will get in contact with the ceiling. By conduction, particles of air get cooler, and then cold air will go down. Okay, so there will be like some sort of convection of cold air coming down, which is typically in a radiant ceiling system about 30–35% of the transfer of heat is by natural convection. And because the performance of a radiant system are critical in cooling, having this extra 30% convection on the ceiling, it's actually a good point. Another big thing on radiant cooling, you really want to work with the low thermal mass. And why is that? Let's say you have you do a radiant cooling on the floor, which is doable. You can do it on the floor, on the ceiling, on the wall. I mean, radiant really doesn't care about gravity. It moves without air. So, yes. And there is no air movement. However, typically on the floor, you have more thermal mass. And that slows down the response of the system. And one of the critical aspects of a radiant cooling system is the potential condensation, which means if the surface temperature on the ceiling, in this case, goes below the dew point in the room, then you will have condensation. What is the dew point? The dew point is that temperature that when you bring your cold beer out of the refrigerator, if the beer is below the dew point, then you see those
droplets of water,
those condensation, that rain that is that drops of water from your cold beer.
So people who are concerned about condensation when it comes to radiant cooling, how do you explain that that isn't really a concern anymore? The technology has advanced so far that it takes care of that.
Yeah. So I mean, the secret is not to have the beer temperature below the dew point, right? So in that case would be the ceiling temperature. And so we need to make sure that the ceiling temperature doesn't go below the dew point. And now we have a control technology that is so advanced so basically we measure, we have like a room sensor that you will just see this circle coming out of the wall. And this sensor measure the humidity, and evaluate the dry air temperature and evaluate the dew point. So we know the dew point room by room. And then we have a mixing valve, just like the one that you use in the shower to change the water temperature. And we adjust mechanically the temperature in the panel so that we don't go below the dew point.
Is all that automated, or does the homeowner need to monitor the dew point and monitor the temperature?
Technically, the homeowner shouldn't even know what the dew point is.
Okay.
So
all that is accounted for in the system.
It's all automated, yes.
But the homeowner sets up the temperature of a room at a certain level, and then all the other background calculations and everything is done by the system.
Yes, and so technically, when you condition a space, you in radiant heating, it's easy, because if you want to reach a high temperature, you just increase the water temperature. In cooling, at a certain point, there will be a limitation in dropping the supply temperature. And you don't want to go too low because of a potential of condensation. And also the technology that we have, like a heat pump, the minimum temperature that you will reach is like 45 degrees, and you won't be able to go below. And so there are limitations in cooling. So if the dew point, so the humidity in the room is too high, then you cannot go too low. Otherwise, there will be a risk of condensation. So now there are options. So we can actually reduce the dew point by extracting the humidity. And this is why typically a radiant cooling system is installed with
the dehumidifier.
We call it more general, like a air treatment system, because it just does not do only the dehumidification, but does more. So we typically have a unit that will integrate in the ventilation system. So basically we do heat recovery ventilation with the dehumidification. So we control the air quality. In this sensor, there is also integrated a VOC sensor that measures the ECO2. So we know the quality of the air. Based on the quality of the air, we decide how much fresh air we bring from outside. And this air, based on the humidity level, we decide if we need to dehumidify the air and make it dry. And by the way, dehumidifying, it's cooling. When you extract water, you are just extracting heat. From
so these are the air magic units that you call. That's what's on your website, the air treatment unit or the air magic units.
So basically, our product is three main products. There is the panel, and with all the fitting and piping. There is the air treatment unit, and then there is the control system. So those are the three key parts of a radiant cooling and heating system.
So does each room have its own climate control platform, or do you just have sensors in each room and it's all controlled at one point?
Yeah, so each room has sensor, and then there are valves on the manifold to activate the panel on different rooms, like with the zoning system. And then there will be, we call it the M-Box, which is our main controller. And this box is basically run our, there is a Messana control platform. There is a software that run into this box and receive all the information from every single rooms. And then we'll do all the activation. So we'll activate the heat pump, the pumps, the recirculation pumps, all the thermal actuator for different zonings, and tell the air unit to do the humidification or to bring fresh air. So it's all automated.
Okay. So I'm assuming the system is a closed loop system. So the water is recycled, whether it's hot water or cold water, it's recycled. So you mentioned that when when cold water runs through these pipes and it extracts heat from rooms, the water gets warmer. And then it goes back to this main unit where it cools down. So in addition to these the delivery system that you mentioned, the pipes, the platform, and the air treatment units, you also have a different unit that cools down the water or heats up the water in winter.
Yeah. So as Messana, we don't do heat pumps.
Okay.
So our system is like a delivery system. That's the right terminology.
So it ties into other units that are out there.
To traditionally for heating would be a boiler, a gas boiler. Now the HVAC industry is moving more toward hydronic technologies, and so the heat pump are becoming more and more popular. And the heat pump, it's a system that basically managed to produce hot water and cold water. And so with one unique outdoor unit, you can heat and cool the whole house.
How does this compare in terms of cost to traditional HVAC? I know there's upfront costs and then long-term operational costs. So how do you convince people? Because I'm assuming it's probably a little more expensive than traditional HVAC systems upfront.
Yes, it is. As everything new and
better
and more high-end is more costly. Well, I mean, first of all, I have to say that unfortunately, here in the US, we are a little bit behind compared to the rest of the world in the HVAC industry. Just to give you an example, the number of heat pumps that are available here in the US are probably less than 10 different brands. If you look in the world, there are hundreds of companies manufacturing heat pumps that are giving their product available, but they are not available here in the US. So
when you say around the world, are you saying that particularly in Europe, they have advanced this technology
Europe, China, like the biggest HVAC company in the world that manufacture heat pump, they don't yet sell their heat pump here in the US. It's because the market is still young, is still growing. There are restriction, certification. So when we started 10 years ago, Daikin was launching their heat pump, but then they left the market. And so they sell heat pump everywhere else in the world, but not in the US. So this is definitely not helping, but it's changing. I mean, since we started to today, there is much more offering, and it's growing and growing. So there is some catch up that we need to do here in the US, and having heat pump available will be
very helpful to grow your business.
For example, in California, everything is moving toward hydronic. So the code is becoming more and more restrictive, that the heat pump becomes almost necessary to pass code. So there are big changes toward the hydronic. So
I'm sure you all have installed the system at several projects all around California. Do you all have you all installed it in homes or mainly in commercial buildings?
The biggest market we have right now, it's I would say luxury home, high-end homes, and we also do commercial. I wish would be more commercial, like in Europe. Commercial radiant cooling is more popular. Here we started to do some like high-end building, like school, office space. We've done an hospital. We've done a city hall. So it is growing, also the commercial, but still the biggest market for us is high-end residential. And you know, going back to the original question, one of the reasons is still the cost. And I think the cost is high because it's a new technology, and contractors that are engaging into the installation want more. It's still a niche, so there is more.
They don't want to be the guinea pigs. They want it to be proven.
Yes, and so when you're pioneering a technology, I think it's always like this. And so the biggest leverage for us to sell are, well, definitely comfort. So we have clients that, you know, they want the best comfort, and no question asked about the price. Okay, perfect. We give you
those
the best.
Are your ideal clients.
Yes, that's our ideal clients, and we have many of those in the Valley. You know, we do a lot in the LA area, New York, all over the states. But the big basin are New York, Connecticut, Los Angeles, and Bay Area. Those are our three big markets.
How would your system perform in a really difficult climate like Texas or Arizona or New Mexico too?
Well, the biggest challenge for us, I mean, for the heating, there is no constraint.
So but we've had 110-degree summers here for 3 consecutive weeks. And I've heard of heat pumps not really working very well in Texas because of the extreme summers. Have you installed this in any projects in Texas?
Well, we haven't done anything in Texas. We have a project that is going right now. But we have done a lot on the East Coast. We have a house in Tennessee and almost every state, not Texas. However, let me tell you this. So this technology was mainly developed in an area in Italy that is close to Venice, and with very
humid,
cold, humid and warm summers, and the technology has been proven very efficient. So obviously, the higher is the humidity, and then there will be more of an investment in the dehumidification system. So I don't think there is any climate concern.
Okay.
And you can always mix the system using some hydronic fan coils. So if there is and we do that all the time. Sometimes we do houses that they are like a glass box, and the cooling loads are so high that if the ceiling capacity is limited because there are big windows, then we'll introduce an hydronic fan coils. And
how does that work? Hydronic fan coils?
It's just a different delivery system. It's we already have the cold water to run into the panel, and then there will be cold water running into a fan coil. Basically, there is a coil and there is cold water running in, and then it will be air system. But on the fan coil, you don't have any restriction in low temperature because there is a condensate pan. So the fan coil will condensate, but you will be collecting that condensation. And by doing that, you will be also absorbing some of the moisture in the air. So
then would the water running in the fan coil units be at a lower temperature than the water running in your hydronic panels? Because you just said there wouldn't be a chance of condensation in those.
Yes, so fan coil and panels will run to 2 different temperatures.
Okay.
So basically, it's from the same source.
Yes.
So same heat pump, and then colder water to the fan coil and a little bit more warmer water on the panel. And usually when we do mixed system in our control, we will be controlling the fan coil as like a supplemental cooling terminal. So we activate that maybe to help the panel to get started, to lower the temperature. And then when we get closer to the set point, then we will stop the fan coil. So we try to limit the use of air in favor of more comfort, basically. But yeah, so I don't see any problem to do that in
really
more
hot
challenging
too,
cases. Yes.
But like you said, it even the systems is amazing. It's far more efficient than traditional HVAC systems, but it's not a miracle. You still have to have properly insulated homes and like sealed windows and all that. So like you talked about these glass boxes that you have had to deal with. That's a challenge because there's so much they have terrible R values, these glass boxes, and there's so much heat coming in throughout the summer. And it's a challenge to condition spaces like that. And it's like the panel is going to be extremely efficient if your home is extremely efficient. So your walls still have to have good insulation, your windows have to be properly sealed. This is just another way to make your home even more efficient.
Absolutely. And there are other challenges in the building the industry right now for home is the space. Those high ceiling and they don't want to give up any more space for ducts.
Yes, that's
simple
true.
as that. And so sometimes we receive projects where we say, okay, so you have no other option. I mean, if you want to condition this space, you need to use the panel, you need to use radiant. Because basically it's integrated in like 1.5 inch of the space of your ceiling, and will be replacing a huge space that will need to be dedicated to ducts. So
yeah, I know as architects, some people, or myself, we have the tendency to just think of a floor slab as a floor slab, and that's it. You don't draw a foot down for your HVAC and your pipes and everything like that. So like you said, this would come in, will be a perfect solution in such instances where the architect just forgot to account for HVAC systems. So it sounds like y'all are on your way. Maybe it's taken you a little bit of time, but y'all are educating the market. Y'all are overcoming the psychological barrier that people think they need to have air blowing in order to condition their space. What are the other hurdles that you have faced trying to bring this product to the US market?
Well, for sure, we needed to bust a few myths. That you. I remember the first trade show we were doing, and people seeing those panels on the ceiling, and you do heating and cooling. You cannot heat from the ceiling, so there is all this. We needed to educate people that yes, you can do heating from the ceiling, and it's actually better. I'm not going to go into the details, but I could speak for another podcast just to tell you why radiant heating from the ceiling is better. So we needed to bust this myth. Then we needed to convince people that condensation is not a risk with the technology, the control technology that we had. I think the other biggest challenge was to convince HVAC mechanical firm, the mechanical engineer that designed the system. And
because it's something they're unfamiliar with. They don't know how to spec it, how to size it.
So there was so much struggle to accept changes in the way that they were doing things. And here in the US, air conditioning, it's very well eradicated, and it's so hard to change. So I think the change here was mainly guided by homeowners and architect. I mean, the best case for us is when a homeowner does his own research, and then I don't want air blowing in my house, and I want the comfort of a full radiant system. So they come to us, and then they will invite their architect or mechanical contractor to work with us. So probably the people, especially younger generations, those are our typical client. Finding out about this technology online and then bringing us the business.
Yeah.
And
I know you sorry, I'm just saying, I know you mentioned earlier that the system is more expensive and it is being used in luxury homes, but since it's far more efficient, I'm sure there's a return on investment within a pretty quick period of time.
Absolutely. Unfortunately, when people estimated the cost of the HVAC system, they don't evaluate the energy saving over the years and the cost of maintenance of the system. An hydronic system is very low maintenance compared to an air system.
How long does it last? What's the average lifespan of this system?
PEX pipe, I think, is warranty for like 40 and plus years. So I don't see, the parts that will be, there are pumps that, I mean, so the pipe itself, it will last, now PEX technology, have very longevity.
So you all have PEX pipes running behind the metal, not metal pipes?
No, this is all PEX.
Oh, okay. I thought those were metal pipes. Okay.
No more copper. Copper will fade, has a shorter lifespan compared to PEX. So, once the system is on the ceiling, you have your radiant surface and it's based on, PEX pipe in the wall. And so the longevity is very high. Then maybe after 10, 20 years, you might need to change a pump or the heat pump. But most likely the system will have the same lifespan of a home.
Wow, that's exciting. Well, I don't see any downsides to using this system. It seems like like you said, in terms of acoustics, in terms of efficiency and uniformity of like the air in your home, it's superior to traditional systems in every sense. So I'm sure you all are growing pretty fast and you're getting a lot of demand for this product. What are the future goals for Messana for the rest of this year and like for the upcoming years?
So we started as a Messana expert in radiant cooling. So over the first 5 years, we really were a pioneer of the radiant cooling market in the US, and we built our name, our brand around the concept of radiant cooling. And to the point that we name ourselves Messana Radiant Cooling. Radiant Cooling is our website. Over this year, we grow a lot in the control platform, and we started to do high-end control systems that were not actually even related to our panel or of a radiant cooling system. Maybe it was just hydronic in general, or maybe a radiant floor to be used in cooling. And so we developed a lot the control platform. And so now we are expanding more as a hydronic technology expert company, and not only radiant cooling. So
okay.
I think we want to become more present in the hydronic industry. And so we recently rebranded ourselves as Messana Hydronic Technologies because I don't want the name to be only associated to radiant cooling.
Yeah.
It is, a huge milestone. but it's not all we have. And so we offer more in hydronic. As I was telling you before, I mean,
that's where the market is going.
Like just add a fan coil or use the radiant floor. As long as the system is hydronic, we have something we have some technology for that.
Well, that's very, very exciting, Alessandro. Thank you for sharing all that info with us and how your system works and how this whole hydronic concept works and radiant cooling too. I'll link your website and your Instagram page in the description. Is there any other info that you'd like to share with the audience?
Well, I mean, I'd like you guys to visit our website. We are building a new website, and if it's a homeowner that wants to contact us, we will be happy to look into their project and help to design the system. We also do that. We work with their architects and their mechanical engineer, and basically we offer a whole package for their conditioning system. And so we'll be happy to work with anyone to deliver the best comfort for the house.
Yeah, you've got some pretty exciting examples of projects that you've completed on your website. Yeah, I went through some of them. It's just, you can't even tell the difference. It just looks like a normal house, but it just functions far better than traditional systems. Thank you once again, Alessandro. I really appreciate it.
Thank you very much for having me here. Thank you. Appreciate it.